right, we're going to take a look at a quick word problem here. This relates to solving systems of linear relations. So with this question here, we have two cyclists, and it says here that they are apart. They leave at the exact same time, and they actually meet each other in 50 minutes. Had they been cycling in the same direction, the faster one would have passed or met, we could think of met the slower one in 5 hours, find their cycling speed. So we're in a situation here where a diagram is helpful. We've got two cyclists that are 25 meters apart. Maybe I'll label this A. I'll go ahead and label this B. And initially, the distance between them is 25 kilometers. So that's known to us in the question. And what we know is that when they leave and go towards each other, so i.e. they're going in a direction towards each other, they can do that in about 50 minutes. They'll end up meeting. Now they flip the scenario on you and they say, okay, suppose here this is A, this is B. They're still the 25 kilometers apart in the second sentence here, still 25 kilometers apart. But it says after 5 hours, the faster one will overtake the slower one. So they leave at the same time in this scenario, but B takes off going in this direction would be the assumption. And A takes off going in this direction. Again, that would be the assumption. And what you're assuming is when time is 5 hours, they actually end up meeting back up. Now here I'm assuming that A is the faster one. Else, if that was not the case, then A would never catch up to B. So I'm just going to assume A is the faster one here. So right away in the question here, they say, want us to find their cycling speed. So I'm going to let those be my variables. I'll let A be cyclist speed A and B be cyclist speed B. Now I need to set up an equation to represent both of these scenarios. If you take a look here, taking a look at scenario 1, this is scenario 2. If you look at scenario 1 here and examine this, cyclist A has been riding their bike for 50 minutes. Cyclist B has been riding their bike for 50 minutes. And I know the total distance traveled between the two is going to add to be 25, right? Because they do meet. And when they do meet, it takes 50 minutes for them to meet. And because A is going faster, it might look something like this. Perhaps A travels to here and B travels to here. But what we do know is the sum distance of their two trips is 25. So 50 minutes is 5/6 of an hour here. So therefore, if I take time times speed plus time ridden times speed, that must equal the total distance of the trip, to which we know is 25 kilometers. So that becomes our first equation. Now take a look at situation number 2 here. I need to make an equation out of this. Well, I know that if I take the time traveled of A, so that would be all of this, that would be represented by 5A, that'd be the total distance that A travels. And if I actually subtract that from the distance that B travels, which would be 5B, I know that must equal 25 kilometers just the same. So now we're in a situation where I have two equations, two unknowns, and I can solve this problem. So to clean this up a bit, I'm going to take equation 1 and multiply across by 6, giving me 5A plus 5B equals 6 times 25. And then equation 2 I'm going to leave unchanged. And again, the deal here is going to be elimination. So I'm going to go ahead and add these two equations. That'll effectively cancel off my B's here, giving me 10A equals, adding these together, I'm going to get 7 times 25. And 7 times 25, as you know, is going to equal 175. Divide across by 10, I get 17.5. And again, this is measured in kilometers an hour. And if A is 17.25, I can sub it into either equation here and solve for B. So I'm going to go ahead and get 5 times 17.5 minus 5B is 25, in which case I end up getting negative 5B equals negative 62.5. And dividing that out, I end up getting my B value is 12.5. So for this question here, the faster cyclist was traveling 17.5 kilometers an hour, and the slower cyclist was traveling 12.5 kilometers an hour. All right, I thought I'd take up this quick word problem, something a little more challenging here, using distance, time, and speed, and relate it to our system of linear equations. Thank you.